Okay. So yeah, this is where I am. Okay. 0.1 meter. So what do I want to do? I want to offset it backwards by 0.1 meter because I measured it and I can see it's 0.1 meter. Code. This is my VS code. Oops, not done it. Any of this. Okay, so this is my URDF. Okay, so I want to take it back by 0.1. Now, what am I taking back exactly? If we go here, and let me make this bigger. I measured from this center, like to this axis where the tie is supposed to fit in, and I'm supposed to take this frame, that is this frame you are seeing here. I'm supposed to take it relative to this other frame. So I'm to move this frame backwards. That's the idea. To move both the frame and the visual. Because if I move just the frame, the leg would still remain. Okay, let me move just the frame and show you. If I come to the frame, this is the frame from the trunk to Taiwan, and I take it back on the x-axis by negative 0.1, which is a minus 0.1 meter, because I'm going backwards, and I launch again. Oh, okay, it went with it. It went with it. Why did it go with it? Went with it. Okay, I'm coming. Hold up. If this is at 0.1, then let me see something. See? Okay. It's in this case that it won't go with it. Okay. So it went with it because this is a rare case where the when is an STL or isn't a DAE. STLs, there's some people that will, or I think Osayande ran into that issue. Some people might, some people might not, where the STL has a different origin, so it doesn't conform to the origin of the joints. So you would have to like move it around a bit, like move it 0.1 forward, 0.2 backward to know where exactly it is landing. So this is a rare case where everything works perfectly because the DAE's origin is at its own origin. So I don't know how to pretty much explain more than that, but it's a common phenomenon where you work with STLs and everything just looks misaligned. So 0.1 was actually too much because I saw some. I can put it at 0.8. The best way to do this is actually open the STL file or the DAE file with MeshLab and measure. But at times that involves interacting with the 3D stuff, and I'm just reluctant to do that. So I mean, not there, but okay. Another thing to consider is, am I facing the right direction? Am I facing the right direction? Because this leg could as well be facing the other way. So I would have to look at the final results to be sure that I'm facing the right direction. I'll go to the final results. That's not the right direction. The right direction is, yep, this is supposed to be on this side. So maybe just something you can tell from intuition. So what I would do is I would rotate it around the z-axis. That rotation is going to be 180 degrees. Rotate by 180 degrees, offset it to the other side, and it should work. It should work. It should. Okay. 180 offset. Hold up. Yeah, Said, what's up?
Yeah, sorry, please. I want to interrupt you. Just I want to clarify something.
Yeah.
Yeah, so the files. I think something is wrong with the one you gave me.
Oh, which is that?
Somehow, if I try to open the files directly from MeshLab, like I'm able to view all other projects except mine. To just be showing me only that final results folder. I think I screen recorded it and sent to your DM to show you. And then I think that's what is causing me up because I was able to write the URDF yesterday, and then every time I try to run it, it's just file not.
What robot do you have?
Yeah.
What robots do you have? Cortex.
I think it's Cortex something.
Cortex.
Yes.
I mean, I remember. I mean, I assembled all of them, but I remember Cortex was special because it's not like the 6-axis robots or the 7 degree or whatever. So I'm not sure you have a problem, but let me see. Cortex, this is yours. These guys.
Yes.
So explain your. Let me just watch a video because it took time to actually make a video, so that should count. Okay. Sorry. Okay. You know what? Said,
Yeah.
your code on GitHub.
No.
This is why I said push to, because now I want to have all your code. I want to have what you're working with. I want to have your URDF, because like I want to see totally. Now you don't remember using any Zacro. That's true, but Zacro still runs at the background for some reasons. So that explains why you're seeing a Zacro file. Everybody goes through it. Something is wrong with your files. Something is not wrong with your files. Let me open your file from my side. I have a default viewer that opens all of them properly.
Okay.
And let me see if MeshLab will have any issue with it. It's unlikely that MeshLab would have an issue with it, but if MeshLab, MeshLab, this is your files.
Yeah.
Yeah, so there basically isn't anything wrong with it, at least from my side. Another thing I need to ask you is, are you running MeshLab from Linux, or are you running MeshLab from Windows? Because you're on a WSL, yeah? Are you on WSL?
No. I'm double.
Yeah, not found. Um, you probably might want to install it again. For some reason, it's not there. For some
What's
reason,
that?
it's not there. That's Olamide. I'll just send it to you. Ross Humble sudo apt install Ross Humble sudo apt install Ross. Are you on Humble or Jazzy? You're on Humble, okay. Sudo apt install Ross Humble URDF tutorial. It should work. URDF tutorial. Yes, this should solve the problem. But it's surprising that you had it before and you don't have it again, because if you did tax 3, you should have it. Okay, so side push your code to GitHub. Can you do that now so that I'll go through your URDF and see what you're talking about?
I've not created a separate repo on my GitHub.
It doesn't take time to create a repo, except you probably want to calm down on this. Just
The thing is,
button click.
when I go back to I just kind of everything was not working, so I deleted most of the files and started again. Like most of the URDF I wrote, I deleted everything because I was like, maybe I made a mistake arranging the files somewhere.
Are you new to programming?
No, not really. Not really noticed.
I'm just surprised that someone said he deleted all the files. What happened to moving them to a new folder? I mean, even when you're writing codes, you don't just delete lines of code, you just comment them out because maybe you will need them, that kind of thing. So now you don't have something to cross check against. So you're basically starting from scratch. So all right, let me try again. Oof. Is it what?
Is it that for example the meshes folder, the folder of the meshes, is it going to be outside the new the package
Can't hear you.
or
Can't hear you. Like I'm breaking. I probably should type.
silicon? No. You hear me now?
Uh, okay, so okay. Okay, now it works. It's working. It's working. Olamide, it's working. It's working. But there's an error. There is an error in your URDF. In your URDF. There's an error in your URDF. Now, see, when I said if we should push whatever you're doing to GitHub, makes life easier for me. Now, Olamide has an issue with URDF. Let it not be that he wants to screenshot his URDF and send to me. Because everybody have been screenshotting things and I've been fixing it that way because, well, it's what we know so far. So I'm trying to like introduce Git. Now, if there's an issue, all I need to do is okay, just push the recent change. Git does not care if there's bug in your code. You push the recent change, I fetch it because I already have I pull it and I make changes on it or I do whatever. Or at least I tell you, okay, this is the line that is wrong, this is what is wrong. I don't know if you would now see how reasonably easy it is. Because tell me, if you had like 300 lines of code, you screenshot all the lines of code for me and tell me you don't know where your problem is. You see, so or you start sending me your program file again. Even if you send me the exact code, I won't be able to still use it because they are like other like 12 files. It depends on, maybe it has a CMake list. Are you going to send all of that through Uno? So that's why I was urging you guys to make sure you upload. Listen, luckily, they have solved the problem, so a win is a win. He solved the problem, so, but I mean, it could be anybody else next time. Yeah, I was working on this. I was reluctantly working on this dog. Like lines. Usually, you get a design. You get a design document. I'll show you one. Can I show you? No, I can't show you. I have an NDA on that. But usually you get a design document. If it's like a proper company, you want to do a proper job, you get a design document that has a lot of measurements that you can use to get your offsets and every other thing that you need. Don't just message me that she doesn't understand one thing that I'm saying in today's class. Were you present in the last class? She wasn't present in the last class. Okay, that's the problem. You have to watch the other class. It seems if you skip one class, everything just turns into Spanish. Okay, I'm on 0.28. So what do? I quickly run a little math. I take this to 0.28. I flip this because I'm supposed to flip it in my head. I flip it. I rotate my tie by the Z axis. I rotate it by 3.14, and then I hope for the best.
Taking me physical listening.
And then you see it's slightly off, or slightly off, but it is coming together. 9 minus 3, 4, 2. I will just get a quick measurement. I will measure from here. So yeah, probably here. I can take 0.04, 0.04, and I can take 0.02. So I will 0.04, 0.02, 0.04 y minus 0.02. So I will go 6, and I would go 0.041. I'm basically just doing I'm just shifting it, moving around in space. So I'm calculating from the x-axis, minusing, adding, and voila, we have it. We have it there. Okay. Okay, now does it move fine? Does it move fine? It moves pretty fine to me. It moves pretty fine. All right, so I can add my next component, which is like the other leg. The other leg, I call it tie 2. By the way, my name is off because maybe Taiwan should be, there are better ways to name it. You can name you can have like a matrix. How do I put it? Put the dog like this. All right. This becomes Taiwan 1, then Taiwan 2, Tai 2 1, and Tai 2 2. It's a better way to understand it than Taiwan, Tai 2, Tai 3, Tai 4. That way, I mean, any of them could be Taiwan. I don't know if you get. So basically, this is my Taiwan, and I'm thinking this should be my Tai 2, and then my Tai 3 and Tai 4. So now it's a bit unconventional because I'm the only one that now understands what I'm doing. So I take this on 2. Is someone raising his hand? I mean, just speak, please, because... Okay, wait. Can you just explain the process again? Explain the question with the package and the correct order. I won't do such because it's on another recording, actually. I mean, the problem is that you have not watched the last class. Said, what's up? I can see your hands up.
That was me asking. That was my question.
Yeah. So that whole process was like 20 minutes to explain, because create the package, except you want me to start.
My problem is I don't know. The thing is, I've tried it both ways, so that's why I'm confused.
What both ways?
Um, this was how I did it at first. I created like the ROS package outside. Then I brought in my what's it called, the meshes inside the ROS package.
Okay.
And then anytime I inside the URDF, anytime I refer to the package name, it's always saying file not found, file not found, something like that. So
You
I did
build
it
the
that way.
package.
Oh shit.
Because in the explanation, you've not built the package, so there's no, that package does not exist actually. It's just created, but you didn't build it. And after you build it, you still won't see it. You have to source it. Yeah. Yeah, that's where the problem is. So yeah, you create, you build, you source. You make any change to the folder, the structure of the folder, you have to build again. Except maybe it's just your launch file that but I recommend, because there are certain things you can make changes to that you don't need to build. You make changes to your URDF, you don't need to build, because we are manually specifying URDF. So each time we run the code, it goes to fetch the latest URDF. So that's why we don't build again. Yeah. But if you're making some other changes to... Yes, I had a lot to do with this. Should I go and watch first? Yes. Yes. If you are making changes like to package your XML, to CMake, to every other thing, then yeah, you have to rebuild compulsory. So I'm here. I've managed to put one of my other legs in place. Very, very crafty method. Sure. And the next thing I will do is the other leg. That's where I was saying the other leg now is tie 2 0 0 0. Now it's the mirror. Do I need the mirror? Do I need the mirror? Let's see. I would have a joint. The joint is going to be Taiwan to type 2. I'm going to just... the X would remain the same. The X should remain the same, right? The Y is in the negative. The Y will be in the positive. The X remains the same. So let's hope that it works. Da 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 da. I don't do something again. Okay, I know what I did. I know what I did wrong. I'm still creating trunk 1 to tie 1 instead of tie 2. So tie 2. Okay. Aha, now we have this. So I'm supposed to get the mirror. It's the mirror I'm supposed to use. So I would come here and I would. The mirror is just like another part that is already mirrored. Either I use the mirror or I mirror it myself. I'm fine with either of them, but since they already provided the mirror, I would just use their mirror. And voila, we have the dog. That is the back of the dog. So some of this, I can move this to, yeah. Okay, so slow but steady, slow but steady. I would now proceed to add the other parts, which would be, I'll just copy this and have it down here, and I'll change this to 3. I'll change this to 4, and yeah, I would also duplicate this because I need 2 more joints. Duplicate this, and it's going to be trunk to 3. Sorry, trunk to 3, trunk to 4, and then my 3 is going to be the mirrored one. Why do I know my 3 will be mirrored? I don't know. It's just in my head. So when you are doing the URDF, you would know where things fit. I can see that my 3 is supposed to be the mirrored one because my 3 is okay. I've closed it. My 3 is oh, okay. I closed it, but I've made changes to the URDF and the changes are not complete, so it's not going to load. Either ways, let me just make the changes. But my 3 is the mirrored part. So how do I work with this? This is going to be positive. This is going to be negative. So this is going to be on the good parts. I remember the value for this should be around 1, 2. Why do I think it should be 1, 2? Because I experimented with something like that. Like, if you remember the first robot we did, we were attaching it to the front, and I remember that from there it was supposed to be around that figure. So I'll change this to type 4. I'll change this to type 3. Else you would run into errors, and then I would run again, and yeah. So it's pretty funny now because you have both legs on this side instead of the other side. But it's bound to happen because I didn't take proper measurements. Will I take proper measurements? No. Am I supposed to? Yes. But it's just faster for me to just take this to like negative 0.08. And again, how am I coming up with 0.8? I can see the URDF I can see the URDF, I can see how everything is. I just have some form of idea on how to place it. So we have it here, which is not bad, right? Which is not bad, but I'm not 100% sure. That's it. So I can turn this off, and then we have just the dog. I can turn off the grid, so like we see it properly. We see it properly, and or we can make it move in a way. Okay, so I'll leave that as it is first. Let me look at their final results. Okay, so the final results, yeah, it's a bit difficult to tell. It's a bit difficult to tell because I can't see all the sides, and I mean this is unitary. It's not like they're going to. It's not like they're going to release their whole documents in public, but it's something I think if I search for it properly, I might see it. The same way I saw these guys. I think this is one of their nice documents. One of their nice documents that has, although it's blogger, it has some dimensions on it. Okay, so uh uh okay, okay. I have another idea. I have some clues actually. I don't know if this looks like this part. Um, this looks like this part. So I might be more accurate if I flip it. Again, if you have proper documents, the iteration might not be that much, but sometimes the iterations are much, and there's almost nothing you can do about it. What would I do? Okay, one of the easiest things to do is to flip the trunk. C14. I can flip the trunk instead of flipping the legs. Okay, flip the trunk. Okay, I'll flip the trunk, and then I can move the trunk backwards. I can move the trunk backwards from here to here. Is 0.18 and 0.18. So I can move the visual back by 0.18 in the x direction, minus 0.18. That was too much. Was it too much? That was too much. You can actually, I told you that yesterday, I can visualize it in your Visual Studio, so you don't have to close and always open the URDF. But in this case, I'm not doing that because that will take a lot of. The trunk is like 64 MB, so that will take a lot of time to load it on your VS Code. It is 0.08. I think we can do so as close. But it's a beautiful day outside today. I don't know what car I'm going today. Yeah, what's up? I can see you. I can hear that you're who is that? Just speak. Okay. Life is beautiful. It's okay. It's gonna do. I am good. I can't even tell if it's even moving. Like, I mean, it's supposed to move, but at this point, it seems it's not making any changes. Actually, isn't making any changes. What am I doing wrong? What am I doing wrong? Base link to the trunk is here, the trunk to the ties. Hold on. I mean, if I put a ridiculous amount here, it should react in a ridiculous way. Okay, I see what's going on. I see what's going on. I see what's going on. The whole thing moves. The whole thing is moving. So instead of moving the joints, let me stick to moving the visual. So let me put that 0.8 instead. Okay, that makes more sense. So 0.18, which was my initial guess. And yeah, makes sense now. Okay, makes sense. So what just happened? I flipped it. I flipped it because on the on the robots, you can see that this head, this part here, this head up here is this head. Is this head. So it's supposed to face this way. So I had to flip the whole thing. I flipped it without flipping the legs. I just flipped the body, and then it got a bit confusing, but either way it's resolved. So we have it facing the right way so far. Everything works well. Okay. What next? What next? What next? The other part of the dogs, which is the lower limb, and I think I have the lower limb. I have hip. I have hip. I have thighs. I have trunk. I have ultrasound. I'm supposed to see what those things actually look like, so I'll have a better picture of what I'm working with. So okay, on here. First I want to look at is the hips. What is the hips exactly? Mesh lab. Mesh lab, it's okay. Okay, so this is supposed to sit somewhere between the ties. It's supposed to sit somewhere between the ties. I think I know where it's supposed to sit, but it doesn't look so obvious, but I think I know where it's supposed to be. Another problem is, should I have two of it or only one? Um, the design looks like I need two. I can, yeah, the design suggests I use two. Okay, what else do I need to check? Ultrasound, mesh lab, ultrasound. Okay, so this is like at the head of the dog, and ultrasound, depth camera. So mesh lab, depth camera, depth camera. Sorry, slight error. Okay. Okay. And then calf, mesh lab, calf. Okay, so this is the lower parts that I was saying we also need. Okay, so I would include a calf link. I think that's the most obvious, another obvious part rather, that I have to include. I'll just copy a link. Just copy a link and calf one, and I'll just change it to calf. It's rotated because I copied that from previous rotation. Let me put that 0. I'm not sure I would need to rotate it, but if I do need to rotate it at any point in time, I would still do that. So I have 4 of them now: 2, 3, and 4. Okay. Then the joints for the calf. Now we're connecting. We're not connecting tie to trunk. We're connecting calf to tie because the calf is connected to the tie. So I would make this calf, no, tie. I can say tie 1 to calf 1, tie 2 to calf 2, but you can see the redundancy in that naming structure. So I can just simply say tie to calf 1, and then intuitively you would know it's tie 1 to calf 1, yada yada yada. So I will do tie 1 to calf 1. Again, you know, as you're copying these things, you're copying the default setting of other listen, other joints you've created. So you're going to have to go through it. I'm just doing like a little separation. I know everything up here is for ties, and everything down here is for calves. So yeah, there are different ways you could separate it, just so you won't be confused. Let me put everything at 000. Let me see where they will spring up, because now I don't know what numbers to use. My calves are supposed to be rotating. I won't touch any of those. I mean, when we spin it up in RVs, we can see what kind of lemonades life gives us. I'll just put everything on 0, 0, 0. Okay. So I'll make this curve 2 type 2. I make this curve 3 type 3. I make this curve 4 type 4. Curve 4 and then type 4 type 4 curve 4. What am I missing? I think we are good enough to visualize something now. So I head over to my window for visualization. Where is my window of visualization? Okay, this is it. So I kill and I run again. And I pray I am accurate. It's clearly going to be heavier now because we have 3 more files in it. But more importantly, we can't even see them. We can't even see them. But the funny thing is, they are there. Like I can see they are there. I can see they are there. And there are no errors. There are no errors. They are there. Oh, Arvis would find a way to always frustrate you. So there are no errors whatsoever. On this side, I can see cow 4. I can literally see all the cows, but I can't see them. And yes, my visual is working. I can see visual. I copied visual with all of them. So what's the issue? Okay, so this is what I'll do. Let me close this file. I'm not saying that's the reason, but that might be a good place to start. Probably close all instances of the cows that you are monitoring. Not the solution, but let's find out. And let's run again. So it got the segments, like it's getting everything, but then we're not seeing it. Like, so I can see here, got segment base link. That's it successfully read that part. It read the calves, it read the ties, but it's not showing them. I can make this random. Aha, that's where it is. I don't know if you see what happened. I made it random and suddenly I can see them. I can see them there. So the typical um mhm. Okay, so what should I do? What should I do? What should I do? What should I do? I'm going to offset it. Let's say I offset it by let's put negative 1. Right? Let me just put -1 on all of them. I just want to see. -1 takes it lower since it's like curves, but then I'm doing it on the wrong side. I'm supposed to do it here on the y-axis. So -1, -1. Let's just make everywhere -1. So it drops it a bit lower than the other parts of the body, and we should be able to see something more different. Okay. I see them down there, tiny legs. Okay, so not bad, but at least we know -1 is too far. I can move them and they move pretty well, so let me bring them back up. I'm going to measure it. I'm going to measure it I will attempt to measure it accurately. It's not possible to measure it accurately, but I would measure from this point, let's say all the way down here, and that is 0.78. 0.78 would translate into 0.22, meaning I would give it 0.22, 0.22, 0.22, and then 0.22. Save, and we go again. So yeah, we have something that looks okay, but it's not ideal yet, but at least it's there. It's there. It could be facing the wrong direction for all we know, actually. So I would go over and yeah, I think it's facing the wrong direction. It's facing the wrong direction. It should be the other way. So I would, instead of trying to move the legs around, I would just rotate it about the z-axis, because I can see I can see that it's the z-axis that is misaligned. So I'll go to the visual and I'll rotate it about the z-axis. 3.14. 3.14 is pi. Like, and pi is 180 degrees. Yeah, right? Pi is 180 degrees, right? Yeah, so by using radians here, so that's why by using 3.14. So I'll see if this makes sense now. Okay, so this makes more sense. This makes more sense. We can take this back, and then the 0.75, and I can put this value on every tie. Can I copy and paste? I can't copy and paste. Can I edit manually? I can edit manually. Okay. There's another way to get this done, actually. When we start doing control, for now we're just using the slider. I want to try and get the angles on the dog picture. So then I move this forward. And then I move this forward. And then I move this forward. Okay, so I would I'll turn off the grid, and we are getting somewhere. We're getting somewhere. We are getting somewhere. So another concern was the hip, because I can go to my final results. I can see that there's an additional hip at the back, right? Like I can see this. I can see this stuff. The leg isn't really connected to the body like that. So I'm guessing that's where the hip comes in. So let me just import the hips and see something. So on the group on it over. Okay. Oh, yeah, they are playing. I think we should distance them first. Yeah. So these are all good ideas. Distance them. I think that's what we ended up doing. But like we distance them by like 1 meter, so they were like at the bottom, that -1. But that randomize is like, because probably you have a lot of links and You can just click randomize and everything scatters and you see where what is. So yeah, okay. I can see something else too, which is the fact that hips, I can see the hips here, like here, right? I can see something that looks like the hips. And if I go to the card and let me view the hips again, I can say mesh lab hips, the mesh lab hips, and it looks like this. Looks like this. It now looks similar to this stuff here. Of course, you can go on Google and get more final results. So you can go on Google and increase this, and I would say, which robot is that? Go one unitary, yeah. And then I can see something like this. It's like the top view, and then you find out that this is the hip. You can see the hip here, and you can see another hip here. So this is a bit easier. It's a bit easier, and apparently the hips also have rotation. I can see some motors on this side, so the hip would be able to rotate. So there's also a hip here too. So what would happen is, let's make it a bit. Let me save this picture. Come on, how many years of using Google? Save. Let's go to documents and what's now that stuff again? Tax 4. No. Tax 4 submission, tax for final results, and I'll say top view. Okay. So what other views would make my life easier? I can see unitary up here. This was a more reasonable. This looks reasonable too. So I will save this. I think I can open image in new tab. Unreachable. Nice. So I can just save it from here. I'll save image as let's call this design documents. It's not documents. Apalative out of design docs.
So please, I want to ask, in the like where you put those is it coordinates they call them now? Like
Coordinates.
are we going to factor the dimensions of the motors there? So
Well, yes, but you need to know that the URDF. Okay, fine. Let me explain what you're saying. The motors that run. Okay, I can show you from here. The motors are not like the. What's better to say this? The motors are not in the URDF. The URDF is for mechanical parts. We use. Let me show you something. If you see here, you have limits, lower, upper, effort, velocity. It's in places like this we factor in like the motor. What speed, what's the limit, the fastest the motor can move? What efforts, like in torque or Newton meter, that the motor would take to move the motor? All those are things that you are not really seeing, right? Now, if you are talking about where would the motor be, mostly the compartment for the motor is already taken care of in one of the URDF. What do I mean by that? Look at this URDF, for example, or look at this for example. The motor is in this part. Let me make it bigger. The motor is like here. You file. So the motor is here. This is where the motor actually is. But this part that the motor is already contained in the body of the URDF. If you see, the URDF is completely see-through, but there are motors, there are PCBs, all the parts are inside, right? We don't need to render everything. We don't need, because we actually don't need anything. We just need to see how the robot looks. Once we get how the robot looks, other variables of the motor, even things as down to impedance, can be factored in with configurations, with other parameters, or param as they call it. So every other thing can be done, but for this particular stuff, we try to be as lightweight as possible. So yes and no, it considers the motors. Does that like answer your question? Okay, so we are at the part where we have to put in the hips, because we have to put in the hips. So where do I want to put in the hips? I'll come down here and I'll just copy a calf joints. I'll copy calf joints. Just copy one, and I would put it down here, and I would go hips one. Apparently, it's one hip to one hip to one tie, one hip to one tie. It's not like one hip and then you connect the ties. I can see that from here. I can see this one hip, this one hip, this one hip, this another hip. So I would change this to hip. I would also duplicate this into 4 places. Hip 2. This looks okay. Now you've done autocorrect to autocomplete. You've not put my hip for me. Hip 3 and then hip 4. But what do I do now? I can run it and watch the world burn, but it's going to give me an error. So let me. Why are you highlighting this for me, please? There are 2 links. Oh, that was a suggestion. For some reasons, you decided to impute 2 hip 4s. So I'll take one out. Hip 4, hip 3, hip 2, hip 1. Okay, good. So I will come down here and let me get a joint for the hips. So I'll call this hip 1. Hip 1 connects. Is going to be complicated. Hip 1 connects its trunk to hip 1, like the main body to hip 1. So I'm going to do some corrections. Trunk to hip 1. Trunk to hip 1. So we're doing from trunk to hip 1. And I would do this for all of them. Hip 2. And then I'll change that to 2. Hip 3. I'll change this to 3. Hip 4. And I'll change this to 4. But remember, we were doing our tie was trunk to tie. So the tie now has to be connected to the hips, not the trunk directly. So we would do this as tie 1, or hip to tie 1, where hip 1 would be connected to tie 1. And then we have hip to tie 2, where hip 2 will be connected to tie 2. And then we have hip to tie 3, where same thing, and we have the hip to tie 4. So we save that. And if we run this, it's going to run, but we might now have to start looking for things, and that's what I want to do. Yep, we see everything. It looks so scattered. We see the hip there, but I'm pretty sure this is like 17 hips in one. If I should delete one hip, if I delete this hip, we see another hip. If I delete this hip, there's another hip. If I delete this hip, and then before the hip goes, so all the hips are in one location, which is nice to see actually. So now let's start positioning them. I probably should measure where things go, but fuck around and find out kind of life. So I will do hip to tie, tie to calf, and then body to calf. So I'll start by putting this at here. Something like 0, 0. Now the thing is, at this point in time, there is no one way to do it, because you might approach it differently, I might approach it differently, but in the end, it's going to get done if you know what you're doing. So we're all on 0, 0. And since we're all on 0, 0, I want to offset by 0.05. No real reason for now. I just want to see how things will come outside. So 0.05, right? And then the one at the back, I want to offset by probably want to offset by 0.6, right? I want to offset by 0.6, 0.26. No, let's make it 0.3 and 0.3. All right, so what happens now? Let's see what happens. Chaos is what happens. But on the upside, this is what we're saying on the upside. So I can make this negative points, this negative and negative, and I'll probably reduce it to 3. And I'll reduce it to 3, save, and we'll go again. And it's gone. Oh, look at it here. It's here, right? But the legs are, so the trunk to hip is solved. Roughly. So let me do hip to tie. I'll make hip to tie 0, 0. So we are starting from the origin 0, 0. I'll make this 0, 0, 2, 0, 0. So okay, this would now be here. So see, we have the legs here now. Legs at this point. What I can do is I can measure the overall width of the overall width is I think it's measure the overall width and then divide it by 2 and space it. Or I can just measure from here to here. 0.05. Okay. So let me take this to 0.05. This is y-axis. So I'll do negative 0.05, negative 0.05, and then I will do 0.05, and then I will do positive 0.05. Hip to tie, yeah. So I would also cancel this and then run. So if I turn off this, we see that small. We have something. We have something. Except that it's facing the other way. There are two things I can do. I can rotate, but rotating is not the solution because we have rotated and we've gotten the perfect rotation. So instead I rotate, I'll just flip the signs on the joints, because if I rotate, it's going to spoil like the legs, since we've rotated the legs before. So flipping the signs gets us here, which to me is a good start. And then the next thing I would want to do is I would want to distance the hips from each other. So I would go to the hip and then I would give it some distance on the Y, say 0.01, 0.01, negative 0.01, and let me give 0.01, 0.01. Yeah. Yeah, so let's see what that resolves into. Let me turn this off. So, are we going somewhere? Yeah, we're going somewhere. Let me make it bigger. Let's say 0.4 and 4. So let me turn this off. And voila, we have something reasonable. So what is left is to, let me get the distance from this point to this point. So we're at 0.02, 0.02. So that's 0.02 on the x-axis, positive x-axis. So I'm going to move it 0.02 on the positive x-axis, which is trunk to hip. 0.02 makes 0.01, 0.01. And we turned off the transforms. We zoom in, and I don't know if you can see it, but we have something better now. We have the dog, we have the joints, the hips there, and there is a way to do collision detection to be sure no part is intersecting with any part, but I'm pretty sure some part might intersect. But till we get into that subject, or into that topic. So another thing now we need to know is, how does the hip rotate? Because the hip also rotates. If I should turn this way, you can see the hip isn't that this isn't how the hip rotates. The hip is not supposed to rotate this way. Why? How do I know? I have seen the dog move. I've seen the dog move. I mean, you can check a YouTube video. I don't know if they have videos that make it clear, but I've seen how it moves in real life. I know that it's not supposed to move like this. It's supposed to. Let me show how it's supposed to move. It's supposed to rotate around the x-axis. So it's supposed to rotate around the x-axis. So what I'll do is axis. This is the axis to specify what axis it rotates around. That's what this axis is for. You create a revolute joint, and then the axis parts x, y, z. That means rotate around y, but want to rotate around x instead, which is trunk to calf. So 0, 1, 0, 1. Let's just do all of them since we're already here. 0, 1, and then 0, 1. Latifa, what's up? So I'll cancel.
Question I want to ask, like, is unrelated to the stuff.
Yeah,
So
absolutely.
you said the way the legs, what did you call it? That joint, that hip joint.
Yeah, the hips. Yeah.
Like the way it rotates, like
Yeah.
like forward and okay. So so that joint looks like a joint that would take steppers. Is it
So
steppers?
so basically we're talking about hardware now, right? And aside steppers, is there any reason why you think it should take steppers or why it should not take steppers?
Okay, so the reason why I asked this question is because of the way the joint looks. It looks like where a stepper would sit. I don't know. I just it doesn't look like a servo. Doesn't look like what should hold servos. A servo.
So yeah, you're actually correct. When it comes to things like this, we use steppers. Let me show you something real quick. We use steppers for things like this. Why do we use steppers? We want to be able to, you know how steppers work, right? It divides the rotation into steps. So depending on how expensive, how precise the stepper is, you can exactly send in signals to like be very sure of where it's going to end up. Like it's not just like the DC motor that is just spinning. I'll show you something. Open arm. Oh, this is one mad project that I was part of, and I'll show you why. Most of the times we use steppers. So this is industry grade stuff, and I'll show you something. DDM 53 or 43, DDM 43. So come over here, DDM 43. Okay, on this case, this was servo. This was servo in this case. So which was it that we used stepper? We used stepper in one of them. Okay. Yeah, I remember. That was this one. That was this. Okay. System architecture. Yeah, it was on this that we use the stepper. This isn't fully documented because this is like my stuff, but yeah, there are times that we need precision and then we use stepper. The times we need precision and then we use stepper. Um, uh, Moto. Let's say motos. There's something I have in my. There's something I'm trying to dig up. It's not like, okay. This is one of those videos. Really dog. Okay. Okay, yeah. So yes, you use steppers for the precision, right? But servos too can be used. I know it's DC that you don't really use because those ones just sends like continuous PWMs. But steppers are used for precision. So most times here that we use steppers. But servos too have some form of like nice control inbuilt with them. So it allows us to still use servos. What I don't know is if on unitary I can unitary go one motor, if that is open source. Okay. On unitary, they are using the bionic joint motor, flexible adaptive, precision bearing. I mean, it must always be precise. The motor is perfectly okay. This is a servo motor with FOC. This is a servo motor. This is a servo motor with FOC. Let me show you what FOC is. This is FOC. It's the control system that is in charge of regulating the motor. So you have the normal servo motor. It could even be a DC motor. Basically, a servo motor is like a DC motor with some form of nice circuitry. So either ways you can supply voltage. It's just that it's easier to supply. It's far easier to supply inputs to a DC and to a servo than to a stepper. Because if you're supplying voltage, if you're supplying signal to a stepper, there is this kind of calculation you always have to do to be able to get what angle exactly you want. So it's a bit more controlled on the input to send to it. But for that of the servo and DC, it's easier to send to them, and then since they already have like a circuitry for control within, so yeah, this is their circuitry for control. So that's behind. That's by the way. Could it be that they model the motor inside too? So basically, I think this relates to the last question you asked. Every single thing is modeled. Every single thing is modeled, but we don't need it. There's no need. Like, I don't see any situation where I've ever had to ask for the models. At most, I would just need to know what's up, Bella. I said Bella. Latifa. What's up?
Okay. So the reason why I asked is because of like measurement or dimension, because these motors, so they have their bodies, so they have dimensions. So
But yeah, let me show you something.
I was asking if it will affect what we're doing, like all those offsets and
No, that's exactly what I'm saying. The URDF that is given to you has already taken into account. Let me show you. This now, for all I know, you see this part, which is the hips. Then let me show you the motor that is in the hips. This is the motor that is in the hips. This is the motor that is in the hips. This. For all we care, that motor could be inside here. The motor could, like, it looks very logical that the motor is inside here. But how the motor turning, how it's, all those are not really our business at this point in time, right? Because we don't need to see the motor. Okay, now let me show you another part. And another part of this is the motor for like the back. Let me show you something. Where is that? I know I put that page somewhere. For example, this now, you can see here that there is, let me see if I can zoom it. You can see this back here. You can see something like this. I don't know if you can see my cursor. My cursor is relatively tiny compared to my screen. But what I can do is I can bring the terminal. I can shrink the terminal, and I can use the terminal as indicator. Now, you see where I'm moving my terminal. You see this place, this this bomb looking thing. It could also be a motor. It could also be like some form of hardware that we have to think of when we're offsetting the hips. But if you look at this down part, you can see that this is a cross-sectional area. This down part, you can see is like there's a cut here. And
Yeah.
technically, they just took up the up cover to show what's inside. Everything inside here is all taken into account by
Okay.
let me show you, mesh lab trunk. It's all taken into account by come on, load by this guy. So
Okay.
the motor now, for example, the motor now would be inside here, like this internal that we are seeing. That's where the motor would be. And then the only thing that we are concerned with is outside here. This yeah, this point here, this outside. So basically everything, that's how it is. Another example that I can give you that would also make my point is the Fanuc, because I just realized that's a good example too of this motor, because Fanuc motors are on the outside, so you should also think of, I mean, the motors are on the outside. How will it affect your URDF? Look at Fanuc, for example. Fanuc has these huge stepper motors on the outside, all these big motors on this side. Where's my tiny terminal again? Okay. So all these big motors here, all these big one down. It's all on the outside, right? But we're not really even concerned. Why? Because they've given us a simplified version of it. If I should now run mesh lab, which link is that? Base link 1, link 2, link 2, link 1. That should be link 1. You see this? You see this odd looking object is actually a motor, but we don't need it to be fully represented as the motor. We don't need the circuitry, we don't need the wirings, we don't need any of that, because all we need is something to tell us visually that this is a motor. And anything we need, if it's speed of the motor, if it's RPM, or any single motor characteristics, we can always specify it and run it in Gazebo. We can always use our mouth and say, Gazebo, okay, you see this motor, the maximum RPM of this motor is going to be 3,000, or the minimum is going to be this, the input is going to be this. You can tell Gazebo that literally, and it's just going to like simulate it without having to know the internals of the motor. So as ugly as this thing look, you can see how this thing looks like stone. I would show you which parts it represents. It represents this down parts. Where's my tiny guy? Okay, I just keep creating a new one because I don't know where the old one is. This tiny thing down here, not tiny, but like it's a big motor, the bigger motor down there. That's what it represents. So
Yeah.
it would also translate to this. It also translates to this down there. So that's the whole idea.
Okay,
But
thank you very much. In case you are wondering why I asked, a I have a small dog here, robot
yeah.
dog. So
Wait, Alpha one on a game money, on game money.
no,
That's
no, I did not buy it. Someone gave it to me. So like the motors are outside, like nothing is covered in this place. Nothing
Alpha,
is
send me picture, beg. Send me picture, beg.
the okay. Let me show you in real time. Um, can I turn on my camera?
I mean, feel free, ma stop to share screen.
Okay. Can you see? Oh,
No,
what's
we can't see
happening?
the camera yet.
My camera is on. Might be due to okay. So I have. Can you see me?
Yeah. Okay.
So these motors, they are outside.
Yeah, I can see it.
You can see the server
Yeah, I can
outside.
see. I can see. I can see those. I can see the servers. Uh so
So that's why I asked if
so the reason why you're even having that problem is because it's not covered.
yes, that's
So
why.
what you can do is you can mentally cover it. Like you don't have to model the servers. Imagine having to model every single it's a lot. Some robotic components are too much, especially the ones that you don't need to model the server. So what you can do is you can measure, for example, those servos are in between, like hold on, if you would even be able to see it, if you can't find. Okay, so basically we have this is a servo. This guy here is a servo. This thing you're saying, it's a
Yes.
servo, right? But you can see that the servo is always in between links. We can see one link here and another link here. Like there are two links that the servo is in between. That's how they all are. Because the servo by design should turn the link, so the servo will be locked in between two links. What you can do is you can model a cover that covers this part, that completely covers the servo. So my first link would be like a box that would assume the servo is inside. So like a box that would cover the links and would cover the servo. So the dimension of the box would be the length of the servo, because it has to cover the servo. You just need to take the extreme link that the servo is in between, and that's like the length of the box. And then the height will be the height of the link, and then you have your link where you have your servo inside, because you don't have to start modeling the servo. So that's what I don't know if you get the whole picture, you get the idea.
Yes, yes. Thank you very much for
Sure, sure.
explaining.
So yeah, we digressed from the ships, and quite frankly, by now you can see everything is coming together. You can see the rough idea. So I was telling you the hips is not supposed to rotate. There's a way the hips is supposed to move, and this is how the hips is supposed to move, like this, like up like this, down, up, down, up, down, up. That's how it's supposed to move. So yeah, basically it's now to model the back, rotate it, and append it, and yeah. So my screen is not shared. Waste of 3 minutes. Okay, sorry. So my screen is shared now. We blame Latifa for that. So I was saying initially the link was rotating, like the normal rotation we've been seeing, but this is how it's supposed to move. It's supposed to move like this, like up. This is supposed to like bend, sort of. That's the thing. That's how it's supposed to move, just bend, right? That kind of thing. Bend like that. That's how the dog is designed. And we've achieved that. So the remaining thing would now be to rotate this guy, that's the hips at the back, rotate it, and then fix other parts, and basically rinse and repeat. It's an iterative process of doing the same thing. So usually in like an hour you should be done with just going over it. Okay, so that's that. Any question, any other thing? Oh my god. All right, so I think prob- we can probably just continue in the group chat. If there's any other issue, just let me know. And then please push your stuff to Git, because if there's any issue, I don't want to be looking at lines of code. For all I know, the issue might not even be in the screenshot you're sending me. Maybe the issue is on another file. So I'd have to build it on my end and go over it. And I'm not even complaining. That's not even stressful, because like it's just pull, create a new directory, build, and go over it. So thank you very much as you all cooperate with me. I have to end the recording.